Hi everyone, welcome to Module 2 of Workplace Math 11, Drawing and Interpreting Graphs. And we are going to start with Part 1, which is Drawing and Interpreting Graphs. So, Introduction to Graphical Representations of Data. Graphical representations of data encompass a wide variety of techniques that are used to clarify, interpret, and analyze data. It is done by plotting points and drawing line segments. The purpose of a graph is a visualization of a data set. A graph should clearly illustrate the general behavior of the phenomenon investigated. And highlight any important factors. There are three main types of graphs that we're going to look at in this course. There are line graphs. Line graphs are used to track changes over short and long periods of time. When smaller changes exist, line graphs are better to use than bar graphs. Line graphs can also be used to compare changes over the same time period for more than one group. In the example to the right, the historical and projected pH and dissolved carbon dioxide, we're able to show the pH and the carbon dioxide on the same graph, so you can see the relationship that as one is going down, the other is going up. Second kind is bar graphs. Bar graphs are used to compare things between different groups or to track changes over time. And the third one is called pie charts. They're also called circle graphs. And they are best to use when you're trying to compare parts of a whole. They do not show changes over time. Okay, that's really important. We won't be drawing any of those in this course, just so you know. Okay, let's look at some examples. Interpreting line graphs. So the graph below shows the average snowfall in Regina, Saskatchewan by month. So I'm going to leave the graph up there and just read the questions off of the bottom half of the page. What month has the highest average snowfall and how much snow fell that month? The snowfall, this axis on the left here shows us the amount of snowfall, and the highest number is this in December, and that is about 21 centimeters. Question or part B, during what 3 months is there no snowfall in Regina? And that would be June, July, and August, because the snowfall then is 0. Not sure that's always the case, but it is on this chart. Question C, during what month is the average snowfall approximately twice as much as the average October snowfall? So we have to do two things for this graph. We have to figure out what the average snowfall in October is. So October, it's just a little over 7, but it's not 7.5, let's call it 7.2. And so we're looking for something that's just over 14. And that would be, so I'm looking here, this is the 14 line. To February is just over and November is just under. So the closest one is going to be February. So February is the best answer for that. Now, I actually I would argue that November is a fine answer as well, because the dots are not very precise. So I think that February or November, or February and November, are okay. All right. Okay, you can pause the video there, go ahead and do the next couple of pages of practice, and then come on back. Welcome back. We're on page 9, and we're just going to look at some guidelines for making line graphs. And you're going to use the same steps whether you're doing a single graph or multiple line graphs, like multiple lines on a single graph. So step 1, and we're going to use the data here in table 1. So step 1 is identify the variable. The independent variable is the one that is purposefully changed by the experimenter. It's always the x. It's always the x-axis, and it should be the first column in your table. Now, I'm not going to say it always is, because not everybody follows the rules all the time, but it is supposed to be the first column in the table, and in this case it is. It's the number of coils. The experiment being done is we increase the number of coils and see how many paper clips it can pick up. So the dependent variable is the one that changes as a result of what you're doing. So it's the thing you're measuring. So here it is the average number of paper clips. And that is going to be the y-axis and the second column of your table. Okay, step 2, determine the variable range.
I'm not going to calculate the range because for this graph, I'm not following the instructions in the notes. For now, we're just going to go to the next page. Okay, now we're on page 3, or sorry, step 3, determining the scale of the graph. And we're actually not going to do it exactly the way it is in the notes here. There's a couple of different ways to do it, and for this particular data set and this particular size grid, the other way works just fine. So I'm going to do the other way on this graph, and then I'll do like this way on the second graph that we do when we do a bar graph. Okay, so the first thing you want to do is figure out how many lines are on the graph. We'll do the y-axis first. So the y-axis is the up and down. Oops, it's the up and down axis. Okay, and on this graph there are 36 lines. Okay, and I'm not going to do the range. I'm going to go from 0 to 14, like the whole thing starting at 0. So if there are 14 paper clips, I want to be able to show 14 divisions going up here on 36 lines. I can go 14 divided by 36, and that's 14 divided by 36 is 0.39, 0.39. So if I actually round that up to 0.5, then that means that each grid on my graph paper is going to be one paper clip. It's going to represent one paper clip on my data. So I'm going to come down here. I'm going to label this right here as 0. And so one thing to know is you don't actually have to label every single line, every single number. On this one I probably could because they're quite far apart and the numbers are small. But it's okay for me to just label every second one. So this would be 2, this would be 4, 6, 8, 10. Sometimes you'll label them every 5. It depends on how small your scale is, okay? You want to, it's whatever is going to look right for your graph. Okay, 16 and 18. So our graph lets us go all the way up to 18. I'm not going to make each paperclip is going to, I'm not going to make each paperclip or each line 0.39 paperclips. That would be ridiculous, because then one paperclip would be like, it wouldn't be on a line. So you want to pick something that makes sense, and you want to use up most of the graph. I'm not using all of it. The highest number I'm going to have is going to be 14. So I'm not using the whole thing, but I'm using a good chunk of it. Okay, my rule of thumb would be you need to use 75% or 3/4 of the graph. Okay. All right, so there's our x-axis, and then we need to label the x-axis, or sorry, my bad, the y-axis. So we need to say what is on the y-axis, and that is average number of paper clips. Okay, and do it, you know what, I'm going to do that better, because it should look neat, and it should be square to the paper, like square to the bottom of the paper. So I shouldn't have done it slanted like that. Paper clips. Okay, and y is always the dependent variable. Okay, all right, and now I'm going to switch colors and do the y-axis. So the number of lines on did I say on the x-axis? That's this x-axis here, and there are 25 lines on the graph, and our values on the x value go from 0 to the highest is 20. So if I go 20 divided by 25, I'm going to get 0.8. 0.8 coils per line. And I'm not going to use 0.8 coils per line, because then my one coil would be like here somewhere, and that would be silly. So let's make it 1 coil per line, and that's going to take up a little bit more space. And so my label on this is going to be number of coils. And I'm going to start at 0. And then each coil is going to be 1 line. So I'm just going to count them out, make sure I have enough. I need to get to 20. There's 25, so that's going to work. And I'm not going to label every single one of them, especially since the number that I'm going to plot, you know what, I'm going to back up and plot this here. This is the data from the table. I'm just copying it over because it's not on the same page. So we have 5 coils is 4 paper clips, 10 coils is 7 paper clips, 15 coils was 11 paper clips, and 20 coils was 14 paper clips. So I really should have had that there first. Okay, so I don't really care where 1 coil is, but I should mark 5. That would make sense, right? 1, 2, 3, 4, 5. So there's 5 coils. 1, 2, 3, 4, 5. That's going to be 10. 1, 2, 3, 4, 5, 15. 1, 2, 3, 4, 5, and there's 20 coils. Okay, so that's all. I mean, I could label the 25, but I don't have any data for it, so I'm not going to. All right, and then I need to plot my points. So I'm going to do that in red so that they show up a little bit better. So when I had 5 coils, I had 4 paper clips. Okay, whoops. Okay, and when I had 10 coils, I had 7 paper clips. Right, that's halfway between my 6 and my 8. And when I had 15 coils, I had 11 paper clips. And when I had 20 coils, I had 14 paper clips. Is that right? Yes. Going a little cross-eyed. Okay. Oops. Okay, so there's my points. And now I need to use a line that's a best fit. So sometimes when you're doing this, you will actually connect the dots, and sometimes you will put what we call the line of best fit. When the data isn't exactly in a perfectly straight line, we create a line that's the best line we can say that goes through most of the data or connects to most of the data. So this is a little bit tricky on the computer, but let's see what I can do. So I'm going to move the end here. Okay. And this is definitely a judgment call, okay? But you can see that my 4 points are not perfectly on the line, but this red line I've drawn represents the data quite well, okay? So that's the line. You must use a ruler for that line, okay? And on this graph, we're only plotting one data set. If we were plotting two sets of data, we would have to do something to make the lines look different, and then we would, like, one of them is in red and one of them is in blue, or one is a solid line and one is dotted, and then you need a legend somewhere on here that says the red line is for paper clips and the blue line is for pieces of tinfoil or whatever else it was that you measured. Okay, and the one last thing that we need to add to our graph is a title. And the title is, I'm going to use basically what was on the table, the information that was on the table. And let me just see if I can move this up just a teeny bit. Okay, so my title is going to be the effect of increasing coils on the number of paper clips an electromagnet picks up. Okay, so I have my title. I have my independent variable, which goes along the bottom, and it's all labeled. They're all evenly spaced. I've got a label for it. I've got my y-axis. My dependent variable has got a label. The numbers are all evenly spaced, and I've got my data, and I've got my best fit line, and I don't need a legend this time because it's just one data set. Okay, so I think that your teacher wants you to see the graph that you've done. So show your teacher, and then come on back for page 12. Bye.
Welcome back. We are looking at part D, interpreting bar graphs, and we're on page 12 of the notes. While looking for a parking space, Olive decided to count the number of different colors of cars. Her results are shown in the bar graph below. Use the graph to answer the questions. So the first question is, how many cars were purple? So we look for the purple, which is here, and we look at the number of cars up the side, and we can see that there were 8 purple cars. So I'm just going to put that number right there. Let's actually just get the numbers of cars while we're at it, okay? There were 4 orange cars, there are 5 yellow cars, there are 3 green cars, and 10 red cars, okay? So having that information right in front of you can maybe make this easier to do the question. So how many cars were purple? There were 8. Question B says, were there more orange cars or more red cars? Well, there were more, orange and red. There were more red cars. And if we wanted to know how many more, we would go, we have 10 red cars minus 4 gives us 6 more red cars. We could also count up. We can start here and go 1, 2, 3, 4, 5, 6. Gets us the same answer. May not that isn't going to work on a more complicated graph. Which color had exactly 5 cars in the parking lot? That would be yellow. How many more red cars are there than green cars? Well, there are 10 red cars and 3 green cars, so that's 7 more red cars. What is the combined number of red cars and purple cars? So red plus purple equals 10 plus 8 equals 18. And which car color is there the most of in the parking lot? Well, we can tell looking at the graph that the red one goes up highest, so that would be our answer. That's the one we have most of. So that's red. All right, so off you go do the practice, check your answers, and I'll meet you back here on page 16.
Welcome back. We're on page 16 of the notes, and we are going to make a bar graph. So bar graphs are ideal for showing information that reflect quantities or the frequencies of things. So the kind of pets, the number of children, people's favorite brands. They're frequently used to display data in science, and they're often the first graphs that students learn to create. And here's the process, and again, I'm not going to exactly follow the process in the steps here, but I'm going to show you a couple of different things. So in the last graph, when we did the line graph, we made our y-axis to show all of the data. And this time we're just going to show the range of the data. Okay, so we're gonna do a little bit of this process here. The independent variable is the detergent brand. And the dependent variable is the average size of the bubbles. Because the size of bubbles depends on which brand you're using, okay? And we're going to do the range for the detergent brand. So our biggest number is 35.8 and our smallest number is 15. And that gives us a result of 20.8 as our range. And we're going to figure out how many grid lines each of those is going to be. So we know that there are 36 lines or spaces on the y-axis. So if our range is 20.8 and we have 36 lines, we get 0.58 centimeters per line. And we're going to round that to 1 centimeter per line. So I have just realized that this grid that we're given is actually big enough to do the 35.8 as our biggest number on the grid the way it is, but I want to show you what you would do. So I'm going to make the grid smaller. Okay, I magically made my grid smaller. And now I'm going to go back. I need to change some of these numbers because I no longer have 36, and that's not going to work like that. So now I have 30. I've got my range is still 20.8, and my number of spaces now is 30. And if I divide that, I get 0.69. And I'm still going to round that to 1 centimeter per line, but this time I can't start at 0 because I've only got enough space for my range. So now what I'm going to have to do is, big picture here, I'm going to start my graph at 0, but then I'm going to put a break in the graph and I'm going to make one of these numbers something else. I'm going to start something below 15 because 15 is my first data point that I need to have. I'm not sure what that's going to be yet, so I'm going to go up here. Well, I know that I have 30. I need one for each. I'm probably going to make this 40 here there's a lot of wiggle room in what you're going to do. Do this in pencil so you make sure that it works. So if that's 40, 1, 2, 3, 4, 5, that's going to be 35. 1, 2, 3, 4, 5, that's going to be 30. 1, 2, 3, 4, 5, that's going to be 25. 1, 2, 3, 4, 5, that's going to be 20. And 1, 2, 3, 4, 5, this is going to be 15. Okay, so now I'm going to, that worked, everything fit on the way I needed it to. I'm just going to erase these lines. I'm going to make them a little bit more obvious. I'm going to put these slashes here to say that my scale is not, there's a break in the scale there. Okay. Okay, and then I need to figure out how far apart what size my bars along the bottom are going to be. So again, I know that I have 25 across the bottom, 25 spaces, and my bars are going to take up some spaces. I definitely want at least one empty bar, empty like column here. I'm going to leave 2 because I've got my my little slashes here. So if I start here, and then I want 2 at the end there, and I want an empty space of 2 there and an empty space of 2 there. So again, I'm doing this all in pencil, right? So what I'm deciding here, because I'm going to have a bar here and a bar here and a bar here. So I've got 1, 2, 3, 4 spaces of 2. So 4 times 2 is 8, and I need to subtract that from my 25 that I have, and that gets me, I should be able to do this, 17. Yeah, 17. Okay, and then I'm going to do 17 divided by 3. Well, that's 5 and a bit, 5 plus. So what this tells me is that I want to make each of my bars 5 wide. So 5 times 3 is 15. So that 15 of my bars are going to be used, of my columns are going to be used up by my bars. I want the spaces in the middle, these ones, this one, have to be the same, but the ones on the ends don't have to be. So if I make, my bars are 15, and then I've got 2 there, and 2 here, and 2 here, that gets me 19. 25 minus 19 is 6, and 6 divided by 2 is 3. That means that I'm going to have an empty space 3 wide on this end, and then I'm going to have an empty space 3 wide on this side. So here's what I'm going to have. I'm going to have 3 and 3 here and 3 here. I'm going to have 5 for my bar. I'm going to have 2 for my space. I'm going to have 5 for my bar, 2 for my space, and 5 for my bar, and then 3 at the end again. Okay, and that will add up to 25. Okay, it doesn't have to be like, I'm not going to do the funny calculation and have my bars be 4.7 or 5.12 or whatever it was going to work out with. I mean, don't make things any harder than you have to. But that's the math that you would do to figure out how to make your graph look good. Okay, I'm going to erase these. Okay, and I'm going to draw my, oh, I've got my lines. Okay, I'm going to draw my my boxes. So, all right, I know I'm starting in 3 from the side, and my box is going to be 1, 2, 3, 4, 5 wide, and I'm going to make it, it's going to be 35.8, which makes it just a little bit less than 36. Okay, so it's going to be that big. Now, you would do this with a ruler, but you know, I'm on a computer, that's not going to work for me so well. I'm going to draw my next box, which is going to start over 2 from where that one ended, and it's going to be 24.8 high. So 24.8 is just a little bit below 25, and it's going to be the same width. The bars do need to be the same width, or else you end up with a really misleading graph, which you will be looking at later. And my third box, my third rectangle, my third bar, is going to start 2 over, and it's going to go 1, 2, 3, 4, 5. Look, I ended up 3 from the end. Perfect. And it's only 15 high, so it's going to go to there. Okay. I'm just going to snap my fingers and fill in my bars. And now I'm going to erase. I did that because that actually takes a long time to do. I didn't want to make you sit through it. I'm going to erase this rough work down from the bottom. I will erase this rough work from the side. And let's put our labels on. Oops, got a little bit more junk down here. Okay. And let's put some labels on here. So down at the bottom, I have detergent brands. And this is brand A and brand B and brand C. And my title for this graph is going to be which detergent makes the best bubbles. And I just noticed that over here I haven't got, I don't have anything labeling what these numbers are, so this is going to be centimeters. Put that in brackets there. Okay, I should probably say diameter is probably what this is measuring. This is the diameter in centimeters. Okay, so there's our graph. Now, I want to just to compare this to what this would look like if we'd used the full scale of the 36 boxes. Okay, so I've copied that graph. The one on the right is the one that we just did, and I've put it on just next to the one on the left, which I did earlier, to show you what the difference is in, this is leading into the next section on misleading graphs. The one on the left, I used the full 36 grid spaces that we were given because I could, and it filled up the whole graph, and that was great. If the biggest bubble was 37 centimeters in diameter, I couldn't have done that. I would have needed to do some scaling. And there's one way you can do scaling is just make each grid space count for 2 centimeters, and then you're just using over half of your grid. The one on the right, what we did is we put this breakdown at the bottom where we're saying it's jumping from, it starts at 0 and then it jumps up to 15. But you can see, looking at this, the one on the left, well, actually what it does is on the one on the right is it makes brand C look like its bubbles are way, way smaller than the other ones. Like 1/5 or like 1/6 or something of the size, whereas here on the one on the left, it looks like the bubbles are half as big. So this is your introduction to misleading graphs. I'm going to leave that there. Okay, and that is the end of part 1. So go do your practice, and then there's a quiz, and I'll see you in the next video. Bye.